Hello everyone. Today we're going to work on a few area, arc, length, sector area problems using a different method where we can use the proportionality between the sector and the circle and use that to solve for the area of the sector and the area of the circle, or the arc or the circumference, or we can solve for radius, length, central angle. There's various things that we can use to solve for these if we use these proportions. In our past methods, we would plug in our information into the problem and then solve for our unknown variables. But this is a little bit different method that might work a little bit easier for some of you. So if we take a look at number 3, we have the area of a sector is 36 pi square centimeters, and the central angle of the sector is equal to 120 degrees, and we're asked to find the radius of the circle. Okay, so we're going to take that proportion where it's the area of the sector over the area of the circle. So we know right now that 36 pi square centimeters is the area of our circle. The sector within our circle, my apologies. We don't know the area of the entire circle, but we can put in a formula to substitute for that, and we'll see how that's going to work here in a second. So the area formula for a circle is going to be radius squared times pi. Now all circles are similar, so we can use that relationship and property to set these proportions equal to one another. Okay, so when we do that, what we can do now is take that. So we also know that this sector is also represented by a 120 degree central angle, and the entire circle is represented by a 360 degree, because it's a circle, so it's 360 degrees. So what we're able to do now is that we could cross multiply here using this proportion. So in the left side of our equation, our pi variables can cancel out, and we're now left with an equation that we can set up and cross multiply with. So on this, I'm going to do 360 times 36 should equal 120 times my radius squared. Okay, now to get our radius squared, we're not just doing an algebra calculation here. I can divide out the 120. Those will cancel on this side, and what I do on one side, I do to the other. That's the golden rule of algebra. We can take 360 times 36 divided by 100, and we can or 120, and we can calculate that out. So 360 times 36 divided by 120 is going to give us 108. So on this side, we'll end up with 108, and it will equal, the thing that's left over here is r squared. Now, we know how to undo a square. We can just go ahead and square root that. When we do our square root, we'll get the square root of 108, and that will equal, the radius would equal 6 root 3. If you convert that into a decimal, it would be approximately 10.4 for our radius. So that is one way that you can go ahead and solve for some of these missing parts in these areas and these sectors and these arcs.